Thanks so much, Asper. Yeah, great.
Oh, are we? Should I start? What time is it? Okay. So it's 12. I think I'm gonna start. I'll also start my timer.
Great. Looks
Okay.
like people can hear you on here. We're good.
Okay, sounds good. Perfect. Hello, everybody. It's 12, so I'm just gonna start my presentation and I'll talk about it in more detail. Hello, everybody also on Zoom. Thank you for being here and please enjoy the pizza also. So today I'll be talking about Earth data and visualization. I am Sonam Sherpa. I'm a postdoctoral fellow with NSF. I'm at the Institute at Brown for Environment and Society, and I'm also part of Department of Earth, Environment, and Planetary Sciences. Before going deep into my presentation and talk, just a brief background about me. I did my undergraduate in Nepal. I did my master's in glaciology in Nepal. Then I worked in an international organization called as ICIMOD, which is International Center for Integrated Mountain Development, where I looked at climate challenges as well as water resource and hazard challenges through field visit as well as satellite data sets. Then I moved to US. I did my master's in science in sustainability from Arizona State University. Then I did my PhD at Virginia Tech, where my research was entirely focused with space-borne remote sensing, more specifically synthetic aperture radar, interferometric synthetic aperture radar, and GRACE, which is gravity-related satellite, which measures total water storage changes. And currently, I'm an NSF postdoctoral fellow at Brown. So for today's workshop, the goal of this workshop is to just understand what is Earth data and its importance, trying to understand basic analysis of these data sets using Matlab, and hopefully be able to load and plot this data set in Matlab. So here is my outline. I'll begin with just brief introduction. I'll go over Matlab basics. What does this interface look like and basic analysis. Then I'll go into Earth data and its availability, where these data sets can be found. And I'll go over codes to demonstrate these data sets. So when we look at our Earth system right now, we have our Earth system is basically changing. We have so many challenges going on. There is melting of glaciers, there is sea level rise. We are seeing flooding hazards, storm surges. And over the past 2 decades, we have seen all these challenges grow. And also, when we look at our population, it is also growing. It means that we have more exposure of people to these kinds of hazard, but also not only population and social system, but also our environment is impacted. So in such kind of circumstances, Earth data and visualization can actually help us understand what's happening in our Earth system, especially in the environment where we have no resources, or where if there is a flooding, it allows us to just remotely sense those information and just look at the changes. So here is one of the example. This is a example of August 16, 2024 flood, which occurred in Mount Everest region of Nepal. Here, you can see 5 lakes. This lake basically overtopped and went down into the bottom lake, and it basically breached and went down to the community, and it destroyed more than 40 homes. Thankfully, there were not many life losses, but it basically swept out the entire community. So you can see these kinds of information through satellite data set or Earth data. So this is an example of planet data, which has a resolution of 3 meters. So this kind of Earth data set can also be utilized to understand sea level rise issues. So this is an example of that. This region is Chesapeake Bay of United States in Virginia. The region in Chesapeake Bay is slowly sinking down in response to this melting of Laurentide ice sheet, which started melting 18,000 years ago. And as the ice sheet started melting, the Glacier 4 Bulge area, the land which was forced upward, it's sinking now, and it continues to sink today. So there's also oceans are rising, but also land is also sinking. So in that case, we have this map, which is an inundation map for a year 2030. This is a scenario called SSB 1-1.9. It means that when we have this climate scenario, when we have this policy and when our world is sustainably focused, we have less greenhouse gas emission, meaning that we are considering this very low greenhouse gas emission scenario. And in that scenario, our flooding inundation would look something like this. And as the time goes, the flooding inundation increases over time from 83 kilometers square to 454 kilometers square from 2030 to 2100. So this inundation actually has significant impact because it can impact communities over here. This region has almost many people living in this area. There is Hampton Roads, Newport News, all this region. And also there are islands, and these are wildlife refuges and wetlands. So there is like tide gauge station, which are measuring heights of the water. So when we have this scenario of very low greenhouse gas emission, the data set or sea level rise change could look something like this. And when it changes to SSB 5-8.5, which is a world where we are emitting all the greenhouse gases without any boundaries, we will have sea level rise of something like this. So further in these slides, I'm just trying to highlight the importance of Earth data because it allows us to understand what's happening on the Earth. Here, this is another example of just prairie pothole observed from SWOT satellite, which is Surface Water and Ocean Topography Mission. This is measuring water surface elevation all around the globe for all the water bodies, including wetlands to lakes to rivers. And this is just an example of one of those data sets. So here, this is from June 13, 2023. This frame of satellite is just showing where there are prairie potholes. So these are very small prairie potholes detected by this satellite. Here, this green is open water, which are highlighted here, and others are water near land and land near water. And if it's blue, it's land. So we can use this satellite just to see what's happening in terms of flooding, but also what's happening in wetlands to water resources, as well as urban areas. So I used all this analysis using Matlab. So Matlab is a programming language platform which is used for data analysis and algorithm development, as well as creating models. This is used by scientists and engineers and everybody who are interested in it. It basically combines a desktop environment with programming language. So if you're a Brown affiliate, you can go to OIT Service Center and download this software, and you can get a license to use it. And if you get the license, you have an account which looks something like this. So I will now move on to more basic of Matlab. I'll just show what the Matlab platform looks like, and I'll just show what we can do from it. All right, so I think because I need to stop my PowerPoint. Okay. So this is Matlab. So it has a command window. It has a,
Can you make it bigger by any chance?
okay, let me see. How can I?
You can do command or control and kind of like scroll up.
Oh yeah, maybe I can just do command and control.
Yeah, with a mouse, you just scroll up and that'll make the font bigger. Like zoom in with control.
Okay, is it better?
A little, yeah. a little
Okay.
bit. Oh,
Yeah.
right,
Okay,
that's
okay.
good.
All right, that's perfect. So this is our command window. This is where you can write your script and save. So this is basically MATLAB platform. And here are the resources where you can access your folder. I saved my M file, which is MATLAB file, in this folder over here. And here, this is a workspace. So I'll just go over these briefly and just to show how it looked like. Okay. So here I can write my codes, or either I can write it here in this space and save it. Hold on, let me move this somewhere. Okay, yeah. So I can write my codes over here and save it. I can create a new file and create my codes here and also save it. But I'll just run my codes from here. So this is my codes. So I've started with CLC, clear all, close all. I always have this because I always have so many analyses going on. And I just first clear my space with CLC. So CLC basically means if I have X equals to 1, Y equals to 2. In my command window, there are so many things going on. So I just want to remove this information. So I just do CLC, remove this information. And in my workspace, I have X variable and Y. So I want to remove, if I want to remove this, I can either do clear X, clear Y, or if I want to remove the entire thing, I can do clear all. So I'll just clear this again. And this close all is for figures. So if I have a figure, something like this, I want to close it. So I'll just close all. So I will start assigning values to variables. So this is what it's doing over here. So I would like to assign a variable 2 to my value 2 to my variable A. So this would look something like this. So A equals to 2, B equals to 20. And if I want to sum this two, my C variable would be A plus B. And if I want to subtract this two, my D variable would be A minus B. So these are really straightforward. And as I type over here, the variables are saved in this workspace. Further, you can also multiply your variable A and B. So for that, you can just do X equals to A multiplied with B. Alongside that, you can also divide your variable. So this is what it's doing. This is division. So I already have my code saved here. So I can, if I want to run this from my already available code, I can go over here, select it, and right click and evaluate the command. Similarly, if I want to get some value with the power 2, I can just do C equals e to the power 8 and get this variable. So this is pretty straightforward. You can also try it on your computer if you already have your MATLAB on. Further, you can assign row vector and column vector to your variables. So let me first clear all my space. So you can assign a scalar value here, x equals to 3. And if I want to assign a row vector to my value y, it will look like something like this. Y, is it very small? It's small, but it is basically this one. Okay. Y equals to, open your bracket, 1, 2, 3, 4, 5. So you have this row vector, which has, if we open here, you have a row 1 with 5 columns. You can also create a column vector. That would be Z. So instead of comma, we use semicolon. 2, 3, 4, and 5. So here we have 5 rows and 1 column. So if I want to get in this Y matrix, if I want to get this variable 5, I look for my index 5. It will give my value 5. So this is index 5. Yeah. Similarly, we can create matrices, something like 3 by 3 matrices or 3 by 4. So this is just an example of that here. Now you have to use both commas, but as well as semicolons to create this 3 by 3 matrix. So for A would be, if I want to do 2 by 2, 2, 1, and now I have to use my semicolon, 3, 2, again, semicolon. So this is my 2 by 2 matrix. So here, this is an example of 3 by 3 matrix, which look like this. All right, so if I go to my workspace and try to open the variable, it will look something like this. So within the matrix, I can transpose this variable. So to transpose it, I can just use this symbol. So for B, I'm transposing my A matrix. So now my B matrix would look something like this. So I have my A variable and A matrix and B matrix. So A is, it looks like this. B is this. Now I want to multiply these two. I can create matrix C, where I multiply A comma B, A multiplied by B. And this is our C matrix. Also with this, we can multiply, we can do a element-wise multiplication. So for that, we have to use this dot symbol. So if you evaluate that, we are multiplying the variable element by element. So our D matrix looks something like this right now. Okay, those were just basics of what we can do in Matlab. Next, I'll go to plotting data sets. So I'm going to create a variable x from 0 to 10, which has a interval of 0.1. So if I do that, I can just select, right-click, evaluate. I created this matrix, this variable. Sorry, let me clear my space first. Recreate this. Okay. So this is our x variable. You can also see in this command window like that, but also you can go to your workspace here and check out your data set. So we have x variable from 0 to 10 with a difference of 0.1. And I'm creating my y variable. Let me clear this, which is sine of the element x. So we have y here. So now I want to plot this x and y. So for that, I'm creating my figure. So let me do figure. So I have a panel figure here. So now I would like to plot this data set. So I'm plotting x and y with a line width of 1. I can increase or decrease this information. Then I'm selecting this color. So it looks something like this. It does not look very clear, so I can change the color. I can choose different variable, or you can directly do red, green, yellow, or black. So I want black color. Oops. Magenta, okay. So if I want to increase the line width, I can change this value here. I can increase the value to 1.5 or 2. Yeah. So for this plot, I can provide a title. So it just says title. Let me see what time. Okay. Title. We name this as sine wave. Label my x-axis. And label my y-axis. So now here I have this figure, but it's difficult to see where the points are. So I want to turn on my grid. So I have my grids on. So that is some examples with plotting. With Matlab, you can also do for loop to repeat your codes multiple times. You can just use your for loop. Here in this case, I'm trying to display my I value 5 times. So I can just run this code and evaluate it. So I have all these values displayed 5 times. In addition to that, you can also use if-else statement in Matlab. So if you want to check if your variable is higher than certain value or lower than certain value, you can just use this if-else statement. So I'm assigning x equals to value 8. I want to check this value if it's greater than 5 or not. This is just a simple example, but this can be used for larger scale data analysis. So here, my value for x is 8, so it should display it's greater than 5, right? So here, this condition is basically saying if the value is greater than 5, display x is greater than 5. If not, just display x is less than or equal to 5. So my value for x was 8. So it's saying my x is greater than 5. Okay. So these are just basic examples that we can do in Matlab. Again, I can save all of these codes, create my own M file and put it in my file here and run the entire thing. Or I can do it one by one. So if you are running a data analysis and you want to look at all these variables, but you want to save it and you want to run it one time, you can just save this M file and just do run. So again, here is the workspace. So I would like to clear variable I. So clear I, or I would like to clear the entire thing. So I do clear all. But you have to be careful when you do this clear all because you don't want to remove some of the variables. So you just have to see what you want to remove or what you do not want to remove. And based on that, you can clear it individually or clear all. Okay. So those were just basic Matlab demonstration. And again, these codes are, I mean, these two interface, which is this tool is available in Brown website and you can download it. So now back to Earth data. So when we say Earth data set, there are many kinds of Earth data. These are some of the example. First one is remotely sensed data. These are sensed by a satellite. Geospatial data, which are available in various websites. Climate data, atmospheric data, hydrological data, bioecological data, and human census data set and urban data set. So based on your preferences, you can download this data set and do your analysis with Matlab or any other programming language. If you're using R or Python, you can also do that in your preferred programming language. So in this talk, I'm mostly interested in remotely sensed data set. For remotely sensed data, these data sets are sensed by satellite. It's similar to somebody taking a picture of yours and I'm sensing you, so I have that data set. But in this case, the data sets are sensed by satellites, right? So here, there are many examples of data sets that are sensed by satellites. Some of them are optical remote sensing, and some are a microwave remote sensing. So there's a difference between these two. Optical remote sensing is basically a satellite system which requires daylight, meaning sun, to see an object. So in this case, these data sets are collected by various satellites such as Landsat, MODIS, Sentinel-2 to observe Earth. But in this case, these satellites require some sort of energy to look at object. In this case, they require light, right? And if there is any sorts of clouds in between, you are not able to see those objects. There is a solution to that. That is synthetic aperture radar kinds of satellites, so the radar satellites. These are these are called microwave remote sensing. So for this, you do not need external energy to detect any sorts of object on the surface of Earth. And this radar data are often used for detection of land movement. It's called surface deformation, vegetation, water heights, topography, and all of this. So there are some of the examples. This Sentinel-1 is from European Space Agency. ALOS-1, it's from Japanese Space Agency. And SWOT, which is Surface Water and Ocean Topography Mission. This is by NASA, CNES, which is French Space Agency, and Canadian Space Agency.
Question. So this SAR imaging, isn't that good for tracking objects that are moving? Or is it mostly stationary objects that you want to sense and?
It depends. So for Sentinel, for SAR, the temporal resolution is sometimes 21 days or 12 days, right? So if your objects are moving my satellite is sensing this one time, but it's gonna sense this after like 21 days. So if your object is at a same place, for example, if you wanna look at Providence from satellite and how the urban area is growing, the satellite can come and track it. But if it's continuously moving, you do not know where the object is, right? So yeah.
What's the data access like? Are the different space agencies pretty open to sharing data?
Yes. So these all are open access, except for Planet, which is a private institute. But these are from space agencies, so they want these data sets to be open access, and these are freely available. I'll also show this in my next slide, how you can access these data sets. That is actually a good segue to the next slide that I have. So for Sentinel-2, which is optical data, you can just go to this website and download the frame that you want and use it. So these are freely available. I can go to the website and show what it looks like. So this is Sentinel-2. And this is from EU, European Copernicus Service. So this is their website. So I want to download a data from, this is High Mountain Asia, this is India. Data somewhere from here. And for this, you can just select this polygon and select your area of interest and go to search. And now you're interested, so I'm interested in Sentinel-2, which is optical imaging. You can also download Sentinel-1. So if you want to download Sentinel-2, you can go here. There are different kinds of levels of data sets. So here I'm gonna select L2A, which is atmospheric corrected data. And I want my data set to have very low cloud, less cloud as much as possible, because this is optical data set and it's impacted by clouds, right? So I want my data sets to not have any source of cloud for my data interpretation. So I can select dates. So September 11 to.
So that control about the cloud coverage,
Mhm.
would that remove any images that have too much cloud coverage?
Yes, it's going to filter all the images. And also you can select dates, and here you are filtering the dates now. So from September 11 to September 12, I guess. So, okay. And also you can filter it by months, right? So if you want only January month, you can filter this here. So for example, if I just want April, May, June, July, August, September, and October, I can just filter it like this and do a search. And based on the dates you provide and based on the data availability, it will show if there is any data available or not. So if it's not showing any data set, it could also be because it does not have images with less than 9% of cloud. So if I increase this, it should show some data. So there are many data sets that are available, which has cloud of percentage less than 68%. So from this, there are many frames, but I'm interested in only this frame, for example. So I can just go here and download it. So to also download these kinds of data sets, it also requires you to have your own account. So you can go here and go to their website and create your account. So here they have this option where you can use your email address and just create it. So that is with Sentinel-1, which is optical imaging. And this is from SWOT, which is a radar data. You can download this data set from Earth Data System from NASA. They have PODAC system. So they have different kinds of satellites and different kinds of data set, and you can just go to their Earth data search and download the data. So I'm interested in SWOT data, which is the Surface Water and Ocean Topography Mission. It's providing water surface elevation globally. So I just want to see water information for lakes or rivers. So I'm just, okay. Hold on, let me skip it. Okay. So I'm interested in SWOT data. I can go here and do SWOT. So they have all these data sets. So I want to download the Pixel Cloud data product. So they have also different levels of products. If it's Pixel Cloud, it has different kinds of processing. If it's raster, if it's vector, these are different data set with different processing system. And this is available in this Earth data. So if you want to download this, you can just go here and download. Same system as Sentinel-1, you can here select the dates that you want. And also select granules meaning here, for example, in this one, we have date of 2023, April 26. This is from this past 503 and cycle. So I can just select those cycles and download those data set. So these are just two examples, but there are more from USGS and other resources, and Planet. Planet data is freely available for all the Brown University affiliates. If you are interested in that, you can also download those data. So back to my analysis. Now I'm interested in only Sentinel-2 data for my coding demonstration. That's why I have Sentinel-2. I'm showing this just as an example. So for Sentinel-2, it provides high resolution information in 3 different spatial resolution. It has 10 meters data, 20 meters, and 60 meters, depending on different spectral bands. So I'm going to use only 10 meters data. It has bands, which is in which has different. It's called bands. So it is blue band, green band, and red bands, and near infrared bands. So using this combination, I can detect if there is water or not, and if there is a water, what kind of turbidity does the water have? So for water index, I can just download this data set and use this. Okay, here is my cursor. For download this data set and use this formula, very simple, and get NDWI to detect water. And if I'm interested in turbidity index, I can use this formula and get turbidity. So here, the goal is to see if the water looks like this, or this using satellite. So I'll just do a code demonstration for that using this example. So there are, when you look at from space, there are these 5 lakes, right? And I want to see in this 5 lakes, which has higher turbidity from satellites.
That's like a lot of mud.
Yes, a lot of mud. So why this is important? Because it means, so this lake basically overtopped and went here, and it breached and it destroyed this community. But what it means is that if it has a lot of sediment, it means that it was getting water from melting of glaciers. And also there was some sort of activity going on in that water. So from satellite, we can detect if these water bodies are active or not. And if it's like, if it's very clear, it means that it's getting water only from snow melt. That means there's less danger of outbursting this kind of leaks, right? So in this one, I want to see what is the turbidity index, something like this.
What's the range of values for that turbidity index? Is that
Um,
from 0 to 1 or something?
-1 to 1. So I will show that. So my next code demonstration is actually that using the turbidity index. Okay. Okay, let me quit my Matlab because it is. So if you install it in your computer, it will look something like this. And you can just go here. And this will load this interface. Okay, so using that Sentinel-2 data for those 5 lakes, I want to see what is the turbidity index. I have already processed those data sets. So I'm just going to go inside my folder and load those data for this workshop. So again, I have this CLC, clear all, close all. I always have this, as I mentioned earlier, just to make sure there's not any other analysis going on. So here, this load shapefile.mat, it is loading my polygons for those 5 lakes. So I can go here, evaluate, and this loads the shapefile. So I have like polygons lat long for those 5 lakes. So there's a latitude, longitude for lake 1, lake 2, lake 3, lake 4, and lake 5. So I have already done those NDTI analysis. So I'm just going to load that, which is a normalized difference turbidity index for the entire frame of a satellite. And I also have this binary layer, which is zeros and ones, which says if any pixel has water or no water. So I'm loading that. I have NDWI, which is normalized difference water index, which shows water or not. And this binary layer is obtained from this, actually. Okay, so from here, I'm using for loop for this. If you see my code, it ends here. It is basically looping around this 5 lakes to get the normalized difference turbidity index and just plot it. So if let me check. If I do I equals to 1, I'm just interested in lake 1. So let me get all the values within the lake 1's polygon and plot that. So let me plot the lake 1 with the normalized difference turbidity index. So it looks something like this. So with this background information, we do not have any context. Where is this right now? So for that, I just want a background with a satellite image. Let me do satellite geo-based map. Okay. So it is the same region where this image is for the Lake 1. This NDTI is for Lake 1. So it is somewhere around here. And this is the normalized difference turbidity index for that lake. So one of your questions was, what is the range of the information of the NDTI? So it ranges from -1 to 1. So if it's higher value, it means it's more turbid, right? So I'm just gonna plot all the 5 lakes with mean value of this NDTI. So for all the pixels within that polygon, you can get mean, median, and standard deviation. And plot that. So here, to run it for all the 5 lakes, I just do this. Okay, let me do close all first because I just created a figure. And let me run this. So this is my lake with turbidity information. My grid is on. And now I want to also add my color map or the color bar. Color bar. So this is the map of that map of lake turbidity for those 5 lakes. So you can see if it's higher value, it means highly turbid, meaning that there is some sort of melting and sediment happening, which is what you can see here. And also there is this lake, which also has some sort of sediment phenomenon going on. So ultimately, if you plot that on a map, it would look something like this, right? So here, this is the bigger lake. We have 3 smaller lakes. Depending on a date, this information would look different. I chose this date because I wanted to see more activity of melting or sediment in this environment, which is a mountain environment, because of warming or because of during the warmer days, there is more melting in these lakes. So as you can see, as expected, this lake, which outbursted to this one and went downhill, this had a lot of water with sediments. It has higher NDTI value, which you can see here. So it does have some sort of implication. I mean, this sort of information is helpful for any sorts of disaster management or to be safe from some kind of flooding that's going to happen in an area. So if you see, using these kinds of satellite, if you see these kinds of information, you can tell there is something going on. And also you can look at time series of these data set and see if the lakes are growing or not. Similarly, this information can be utilized in any source of environment, whether it's coastal area, whether it's in Virginia or Providence, or anywhere else in the world. So just a summary of what we just went over. So we looked at different kinds of Earth data. We visualized them, and Again, the main point is that this sort of data set allows you to understand changing environmental processes and also detect change. There are also many satellite data sets that can be used to detect flooding, right? People have been doing that. And also the Earth data set allows a opportunity for us just to not only to look at what's happening with water, but also what is going on right now, and we can project that to the future and plan based on that. So many of the examples that I showed were water related and hazard related, but you can also use different kind of Earth data for urban areas or populations. So especially with building increase in buildings, you can see it over time based on the temporal resolution of the satellite and see how the Providence area has changed or how US has changed. You can also look at fire information or any sort of biogeochemical cycle, which is more with the water also. So lastly, Matlab helps in investigating these kinds of environmental challenges that we are currently seeing and can also be utilized for our own societal benefit. That is all I have, and I would be happy to take any questions you may have. And thank you for listening to me. Yeah.
Like recently, there's been like natural disasters in Florida, and like also yesterday, last night, there was also like the aurora or killer lights. So are there any special ways that you would like look at that? Look at these things like relatively real time, like not like after it happens. And then, for example, like, I don't know if you plan like where to see the aurora, for example, like yeah.
Yes, that's a really good question. And the question was, there have been many events, like flooding events happening for the people in Zoom in Florida. And the question was, we are seeing all these events instead of getting these flood maps in days time, can we see it real time? And that was your question. And in addition to that, can we project it or on the ocean also, can you see those information, right? Okay. Actually, that's a good question. And the answer to that is yes, you can track. So atmosphere, so when I say Earth data, there are also, I only looked at remotely sensed data sets, but there are also atmospheric data, which I do not use these data set, but these are also available. And atmospheric group people, they have been tracking wind speed and how it's flowing over the area, and they are actually tracking it, right? NOAA, I don't know if you've heard that institution, people from there, they also look at this information. And another question was, can we come up with real-time water mapping, which I think is a really great question. And that is something I'm also very interested in doing in my own research, especially to see what's happening currently right now. But one of the limitation is that we have to wait for, so with remotely sensed data set, we have to wait for that second satellite to pass and get the data and see it. But with more and more satellites, so if there's like daily satellites and with like coverage of more satellites, there is a possibility in the future for sure.
I suppose these companies that provide weather forecasts use these atmospheric data sets all the time, right?
Right.
To like update their forecasts.
Right, like meteorological scientists, right.
Difference in like, I saw that you had R and a comment song. So how does the like how do the geospatial like packages compare across like Matlab, Python, and R? And then like, why do you prefer one? Why?
That is a really great question. So one of the limitation with Matlab is that you have to be affiliated either with some institution. It is not freely available. So with Python and R, these are freely available. So if I am somebody in some parts of the world where I do not have access to this kind of programming language or the software, it's gonna limit my ability to understand or analyze data. So that is one limitation Matlab definitely has, and I hope they make it open access for everybody in the future. But with the Python and R, I have also utilized those programming languages, but not very often because most of my research have always been with Matlab. So I just use Matlab. I prefer also Matlab, but with Python and R, I think maybe, yeah, you guys also can maybe talk about it. There are so many resources, and also since it's free, maybe there are more packages and more advancement in that field. And for me, I prefer Matlab because I've been doing all my research throughout my PhD to now in Matlab. Yeah.
That's great.
Yeah. Oh, sorry, over the Zoom, the question was, which software would I prefer using, or, yeah, and which is better? Yeah.
That might be a good question for Arlen, because you use them all, right?
Yeah.
What
I
do you think?
There's advantages, and also it's a matter of preference, you know?
Right.
Like when I
Yeah.
started, I used Matlab too,
Mhm.
but then I moved to different fields of study,
Mm,
and the communities in those fields have their own preferences.
mm.
Right.
Products are kind of like based on specific tooling, so you just need to either adopt what they're using, or, you know, go against the grain and build your own tooling in the other tool that nobody else is using.
I think beyond personal preference, though, I mean, to your point, like the fact that it's not open source, I mean, like, from my perspective, there's such an emphasis on reproducible research. Like, I would claim that if you release code for Matlab or SAS or whatever, that's not open source. Like, or that's not reproducible in the same way as like you release your Python, your R code, because
Yeah.
if someone can't install Matlab or can't install SAS or can't install whatever, they can't
Right.
reproduce it.
Right. Yeah, I think the question is also of like accessibility for sure. And also if I do not have resources, I won't be able to use it at all, which is a disadvantage. Yeah.
So I'm a biostats major, and then do you see any like research linking geospatial data with like public health, for example? Because like the water or the weather, for example, it might have some kind of relationship with
Mm-hmm.
overall health of the region.
Yes. Yeah. For Zoom people, the question was, have I seen any kinds of researches that linked public health data set with the geospatial data sets? Yes, the question to that is yes. For my PhD, I produced this flood maps. One of the case study was in India, and there was a person who wanted to look at impact of after flooding. There is many things happening, right? There is this huge disaster, but also it causes diseases because there is like all the sewage system mixing with water, and there's salmonella in this water system. So they wanted to utilize like flood maps and also use their own matrix. I'm not aware of many of the details with the public health data, but they have been combining this two different field satellite data sets to understand if there is like salmonella, which is I think bacteria impacting the community. Yeah.
Thank you so much.
Okay. Okay, thank you everybody for joining. Thank you everyone on Zoom.